Greetings. This video is an attempt to show you some of the most important features of MATLAB that you'll be using in Physics 472, or at least the ones that I think are important to know to get off on the right foot. So first of all, if you bring up MATLAB on your computer, hopefully you'll see a window like this one. And it has sort of how to open and save and create new files, and how to run things are the most important sections here. And then this window is broken up into a few different areas. Here's some files that are available in the current folder that you're in. Over here is the programming window where you'll write in commands to your program, a command window where you can run your program or look at variables that are in your workspace. And then your workspace lists your variables that you have at the moment. So anyway, the way you're going to use this usually is to create a MATLAB script file or a .m file. And in order to create a new one, you can either click on this thing right here. You get the little plus button, creates a new one. Or you can go over here and you can say new script. Okay, and we'll just work in this one right here. The comment character is the %sign, so you need to know this. So, because I would like you to comment your files. In order to create a new variable, you just type in something like x equals 5. There it is. And usually we put a semicolon at the end of it, which keeps the program from reporting the value of that variable when we run the script. So for instance, we'll just do y equals 4 here, and then we'll run this script, and you'll see what will happen down here. It's going to ask us to save this, and so we'll save it as test2.m, okay? And it ran it, and you see it reported y, but not x. That's because we didn't have a semicolon after the y line. All right, so in general, you're going to want those semicolons. One of the great things about MATLAB is that you can create vectors and then do math operations on those vectors. So instead of saying that x is equal to 5, we can say that x is equal to 5 to 10. Okay, so let's run this. Now, I don't notice that here, but it does tell me over here in the workspace that x is a vector 5, 6, 7, 8, 9, 10. Or I could look at it right here by doing the same thing, just type x and it will report its values to me. I can make that a vector that has a different spacing, like 0.5, in this manner. Okay, so let's run it again. And you notice now over here, it's got too many elements for it to bother reporting what they all are here. But if I want to know what it is, I can learn about it by typing it into the command window. So that created a vector x. One of the great things about MATLAB is that you can do element by element math. So we could do x times x. Notice the dot that I have here. The dot is a way of saying to MATLAB that I want to multiply x by itself, element by element. So the first element times itself, the second element times itself, rather than doing matrix math. If I tried to do this, I'd get an error right now, but there are ways of multiplying two vectors together in a matrix manner, for instance, to get a dot product. That would be just a scalar output, that kind of thing. So usually in this class, we're going to do element by element math, in which case if you're multiplying two vectors together, they better be the same size, and you better put this dot in front of the operator. So I could also use plus or dot dot divide, like this, right? Yeah, any way you want it, okay? So for instance, if I create this right here, notice that y is a vector of all ones in this case. Or if I do this, then y is going to be, the square of each element. So that's really handy for us. Okay. Now, let's look at an example program. Okay. To start with, I'd like you up top to put some comment lines that say what lab it is you're working on, what the file name is, who you are, who your partner is, and what the date is, and what you're planning on doing, or some brief description of the file. Okay. MATLAB can run these scripts in sections. This is nice because that way you just create one file and keep working in it. And if you need to rerun little sections of it to produce figures or something, you can run sections. So in this case, I'm setting up a couple of things at the top that I'm going to need in all sections. This is a conversion factor from degrees to radians, and this is a vector of points in time running from 0 to 1 second, spaced by a millisecond, as you can see. This section right here starts with the double comment character, and it goes until the next place where I see another double comment character. So everything in yellow here is a section. I define the frequency, the angular frequency, the amplitude, a phase shift, and then I create a volts variable, which is going to be a vector because it has this time vector inside it. I didn't really need to include this dot right here because W is just a number. It's not a vector. It's just a number. So I don't really need to have the dot there. You can put it there if you wish. If I run this section or the whole program, actually I need to run the whole program in order to get these variables defined in the first place. So let's do that. What you'll notice is it brings up a plot automatically. This is one of the nice things about MATLAB is it's an interactive way of scripting things and plotting things, and then after you've run the script, you can do things like, hey, what's my value of omega? What's my value of A? You can investigate how the script left those at the end afterwards to help you debug things. Okay, so this section right here goes to figure 1 and then plots up volts versus time in figure 1. I would like all of your plots to have X labels and Y labels and titles on them, just like this does. The font size thing here to make it font size 18 just makes those big enough to read. You might investigate how to make the axis tick labels bigger since those are a little small as well. And you can play around with making the plot look nice interactively. By the way, you have this plot over here, and it's actually possible to interact with it. So you can zoom in on a section of it, okay, just to look at it, or you can zoom out. You can use a marker that will tell you what the XY values are at various places. Lots of stuff you can do over here. So just be aware of that. In your script, you can have different sections. So here's another section. Now, I originally had commented all this out. Another nice thing about this editor is that you can comment and uncomment big sections at a time. So let's actually look at this one. This one goes to a figure 2, so it's going to pop up as a new figure, and it's going to plot something else. So I can run just this section, not the first section, and plot up the second graph like that. What's nice about that is that if I want to go back and do just this section, I can do that again as well. So I can play with have a big long program for one lab and then just have different sections for the different parts of the lab, and I don't end up having 5, 10 files sitting around in some directory. It's just much easier to do things that way. So I recommend that, running sections at a time, using vectors rather than for loops, which is they're more efficient and they're a lot easier to code with, and of course eventually saving your file somewhere. Now, as we were running here, I believe it was running and saving at the same time, but you can also save the editor document. It'll ask you where the first time, but after that, you're going to want to keep saving it so that you don't lose it. Okay. I am not. It may not actually be saving it when we run it, so be careful about that. Definitely save your work as you're going along. Now, one last thing: these figures right here. If you want to include these in a report, I recommend PNG files. So if you go over here to save this, right, it's going to ask you what format to put it in. I do not recommend saving it as a MATLAB figure. I don't ever want to receive in an email MATLAB figures. I would like to receive PNG files, which is an efficient bitmap kind of file. So we can put that here, and we can call this, fig1. If you're going to, you may end up having to send me files, and if you do, I'd really like it to be a file that has enough labels that I can tell it's yours. So it would be like, P472 lab 1, your initials, your name or initials, figure3.png or something like that. And anything that has enough information in it that I can tell what it is from the file name. Anyway, PNG files rather than fig files. You could do JPEG, but it's not as nice for bitmap graphics like this. So I think that's it. Just remember to program in scripts, use the command window to investigate things, especially if things are going wrong. You can see your workspace variables over here. That's another convenient thing. And use vectors, run things in sections, and that'll get you pretty far. So good luck.